let's begin. The first thing I want to let you know that inequalities, let's write this down, inequalities have multiple solutions. Inequalities have multiple solutions. Let me translate that into translate that. What that means is that there are more than one answer. There are a variety of answers. For example, if I'm graphing something that looks like this, y is greater than x, where are all the y's greater than x? It looks like this. This is what the answer looks like. It's a dotted line that goes diagonal right through the middle. And the answers are on this side of the line. So we shade it.
So when we shade it, how would we figure out like the number answer?
There isn't just one number answer. There are tons. There are multiple number answers. The multiple answers, where it's shaded, is where the solutions are. The shaded part, let's write this down. Shaded part is where the solutions are. That means no matter where I am in the shaded part, that's an answer that will work. I'll pick one example, just one, and show you that it works. Okay, like I'm going to pick this point that's right there, this point right there. That's just one point in the shaded part, but there's lots of points that are there. Let's see if he's here. Yeah, he's here. Thank you. This point here is the point, let me see, -1, +1. That's what that point is right there. And I want to show you that it works. When x is -1 and the y is 1, is 1 greater than -1?
Yes.
That means this point here is a solution to that inequality. You can have a variety of solutions. You have an infinite number of solutions. Because it could be this point over here, it could be this point here, it could be this point, it could be this point. All this shaded part is made up of so many points that you cannot count them all. That's why I say there are infinite number of solutions that work. Because there's so many, you can't count them. It's the biggest number you can think of. But guess what? There's an equal amount of wrong answers as well. These ones on this side of the line don't work. If I were to try to use this point right here, this point here is 1, 0. Let me put a dot right there. If I were to try to plug in 1 for the x and 0 for the y, does 0, is it greater than 1? That's not a solution. There are infinite number of solutions on the non-shaded side. So you have a 50-50 shot when you are graphing, and that's what we're going to work on today. We're going to work on how to graph. But the first thing I needed you to know is that these have multiple solutions. That's why we shade. The shaded part is where the solutions are. How do we check to see if something is a solution? You plug it in. How to check for a solution. How to check for a solution. I'm going to write that down real quick. And then Let me give you an example. 4x plus 3y is greater than negative 2. And I'm going to put number 14, and I'm going to circle it because this is like number 14 on your worksheet today. 4x plus 3y is greater than negative 2, and there's a solution which is negative 3 comma negative 1. I want to see, is this ordered pair, is it a solution to this inequality? How do I check? I just check by plugging it in. Plug it in and see if it's true. Okay, so let's plug this in. This is your x, this is your y, and you have 4 times x plus 3 times y. And you're going to see, is it greater than negative 2? We plug it in. So I plugged in x comma y. And 4 times negative 3, I need you all to tell me, what is 4 times negative 3?
Negative 12.
Good. I need you to tell me what 3 times negative 1 is.
Negative 3.
And I need you to put together negative 12 and negative 3, which is?
Negative 15.
Greater than negative 2. And you are going to see if this is true, it's a solution. If it's false, it's not a solution. I'm going to write that down off to the side. True means it's a solution. It works. False means it's not a solution. Okay. Is negative 15 greater than negative 2? If you're, well, it is not. This is not true, right? This is false. So this is not a solution. Keep in mind, if you ever get confused as to what's bigger is whatever is bigger is on the right side of the number line. So I kind of think of a number line like this, and here's 0, and here's 15, and here's negative 15. Negative 2 is right about here. What's bigger is going to be on the right. The numbers on the right are bigger than the numbers on the left for the number line, in case you've forgotten. Okay, so this is how you're going to do some of your problems by checking. But what you're also going to have to do is to graph. So let's go ahead and talk about graphing inequalities. I'm going to scoot this up a little bit. And this says graph. I want to graph y is greater than or equal to x plus 2. Y is greater than or equal to x plus 2. This is going to be similar to number... No, I didn't even do that. Okay, I'm going to leave this here, but I'm going to write down what it looks like on number 3. Okay, this is what it looks like on number 3. Right there. Number 3 says negative x plus y is greater than or equal to 2. That's what it says. This is number 3. I just didn't do anything to it yet. So when you're going to graph these things, the first thing that you need to do, I'm going to put it over here. Put in to slope. Oh, I'm going to need to recenter that just a little bit. Put into slope-intercept form. If you do not know what that means, it means I want you to get the y by itself, the y, the mx plus b. I want you to get into that form. There will be some sort of inequality here instead. It's not always going to be an equals, okay? It might be a less than, it might be a greater than, It might be a less than or equal to. It might be a greater than or equal to. But we're going to put it into this form where the y is on the one side and the mx plus b is on the other. So for step 3, or number 3, when we're working on this, the first thing I need to do is I don't have the y by itself. So sometimes you're going to have to add x to the other side to get it to be y is greater than or equal to x plus 2, which is what this is. That's step 1. Step 2. Use the b. Then use the m. Okay? So let's go ahead and set up our graph paper real quick. X, y. So the very first thing I need to use the b. Do you know what the b is of this equation is?
2.
That means this is where it crosses the y-intercept. From here I go up 2 spaces and I put a dot. I use the b, make my first dot. From this dot, I then use the m. Do you know what the m is in this problem?
1.
I'm going to put the invisible 1. How come it's an invisible 1, Mr. Promo? I don't see anything there. Why isn't it 0? Because how many x's do you have? You have 1x. It's the easiest way I can explain it to you. This means we go up 1 over 1. Up 1 over 1. So that we know what our line is going to look like. Now, before you do anything else, don't forget to go to step 3. If it is less than or greater than, we make a dotted or dashed line. If it's less than or greater than or equal to or less than or equal to, we make a solid line. Basically, if there's a line underneath the inequality, then that line needs to be solid. It means or equal to. It means anything on the line is in bounds. If you do not have a line underneath it, then your line needs to be a dotted line or a dashed line. Okay, so in this problem, is this a solid or is this a dotted line? So I'm going to draw my solid line. And then we're going to have to shade. How do I shade? You have to test a point. Test a point not on the line. Test a point. Oh, that's hard to see. Let me scoot it up a little bit. Test a point not on the line. The easiest point to test most of the time is 0, 0. So here's what I'm saying. Either you're going to shade below this line or you're going to shade above this line. All the solutions are either on one side of the line or the other. There is no gray area. You're either in or you're out. You're a solution or you're not a solution. You're either shaded or you're not shaded. That's how it is. It's black and white. Okay? So let's test this point 0, 0. This point right here. I don't know if this point is a solution or if it's not a solution. If it's on the shaded side or the non-shaded side. Let's figure it out. Let's plug in 0, 0. And let's do this in our head. 0 plus 2. And let's see. Is 0 greater than or equal to 2? Is this a solution? So this point that I'm pointing at, since I've tested it, is this on the shaded side or is this on the non-shaded side?
Non-shaded.
Okay, let's call this the sunny side. Right? There's no shade. It's not the shadow. The shadow's not there. Right? The other side is the shaded side. You've tested the point. And just so you know, I'm thinking of like the sun and the earth. There's one side that has sunlight on it, and there's the other side, which is the dark side. Or, as Pink Floyd said, the dark side of the moon. There's always the dark side of the moon. Okay? You guys are too young to know who Pink Floyd is.
No,
it's a band
we're
from...
really not.
How many of you have heard of Pink Floyd before? Oh my goodness, I'm surprised. Your parents have taught you some decent music. I'm proud. Oh, Metallica. Woo! Getting me excited now. Okay. Let me show you. That was number 3. I need to show you something like number 9. Number 9 looks like this. X minus 2y is greater than negative 4. I'm going to go a little faster this time because I feel like you know it. Plus, I've been lecturing for 17 minutes, so I definitely need to pick up the pace here just a bit. Sometimes when you do problems, you're going to have to add that one little extra step that a lot of people forget about. And so I'm going to put a little side note over here. I'm going to put it right underneath this thing right there. And I'm going to put a little star. When you multiply slash divide by a negative. When you multiply or divide by a negative, the inequality flips direction. When you multiply or divide by a negative, the inequality flips directions. This is one of those things that I like to highlight because I know that a lot of you will forget this little step. The difference between an A student and a B student is this little thing right here. Okay? The A students remember it. The B students forget about it. Okay? Here we go. In this problem, let's get rid of the x. Let's subtract x to this side because I want to get it into slope-intercept form. And I have negative 2y is greater than negative x minus 4. I'm trying to get the y by itself. Since there is this negative 2 and it's multiplying the y, the opposite of multiplying is divide. I divide by negative 2. And I don't just divide this by negative 2. I divide everything by negative 2. Whatever you do to one side, you have to do to everything on the other side. But I divided by a negative. So I have to remember what I just highlighted in yellow. That means this inequality is going to change direction. Instead of greater than, it becomes a less than. It has to. This is why. I'm going to leave this as a fraction since 2 does not go into the invisible 1. But a negative divided by a negative is a positive. And I'm going to write that like this. 1/2 x. Negative divided by a negative is a positive 2. And now, I can graph it because I know what the B is. Here's my X, here's my Y. The B is 2, so I'm going to go over to the 2, put a dot. From there, I use my slope. Rise 1, run of 2, rise 1, run of 2, up 1 over 2, up 1 over 2. I could even go negative 1 down and to the left 2, a negative and another negative. Now let me go over back to my step. Is it a dotted or is it a solid line? Okay, so that means anything on the line is out of bounds. Anything on the dotted line is not a solution. If it's solid, it means it is a part of the solution. Okay. And I have to decide, am I going to shade above or below? The easiest point to plug in usually is 0, 0. We're going to test that point. How do I test 0, 0 to see? I plug in 0 here and 0 there. 0 for y less than, I know what 1/2 times 0 is. That's why I use 0, 0, because it's easy when I do the math. Plus 2. Is this a solution? This is on the side that's with the solutions. Is this the shaded side or is this the non-shaded side? You have to shade. All the solutions are on this side. There's our answer. The last 2 examples I'm going to show you. And then I'm going to give you one shortcut and we're done. Don't forget about horizontal and vertical graphs. If I have a horizontal line, it's something that might look like this. Y is less than -3. If I were to graph that, anything that's y and a number, there's no x at all, is a horizontal line at -3. This is where all the y's are -3. And I'm going to make it dotted. Why is it dotted? Because there's no line underneath there. Now when you're doing this, you could still plug in 0, 0 if you want to. Or let's just use some common sense. Okay? Here's -3. Here's -2. Here's -1. Here's -4. Here's -5. I want y values that are less than -3. Are the numbers below or the numbers above, are those less than -3? Think of examples of what the solutions are. Does -4 work? Does -1 work? Which one works? The top or the bottom? Do you know? If you're saying the bottom, you are correct. -5 is less than -3. -4 is less than 3. I can even go all the way down to -100, and that is less than -3. Those are all the solutions that are below the line. What about a vertical line? If you have x is greater than or equal to -4. 1, 2, 3, 4. Here's where x is -4. That would make a solid line. And I want values that are greater than, that are bigger than -4. That's either on the right or the left. Do you know which side this is?
Right is right.
Right is the shaded part. When we shade it in, we're saying these are all the solutions. The last thing I'm going to do is I'm going to give you a... No, that's it. That's where we're going to stop right now. Okay? We'll stop.